Okay, so getting an index form first, that's the same as root x over x squared minus 1 over x squared. So that's x to the half over, I can write that if I want to, x to the half over x squared minus 1 over x squared. And I've got a power divided by power, so I subtract the index, so that'll be x to the minus 1.5 or minus 3 over 2, and minus, that'll be x to the minus 2. So that is, so the derivative f dash of x would be, now I just have to differentiate this, minus 3 over 2 x, power decreases by 1, so it goes down to minus 2.5 or minus 5 over 2. Minus 2 times the minus 1 is plus 2, and that'll be x to the minus 3. And that'll do nicely. Part 2, same sort of thing. X root x over x root x minus 1 over x root x. That will be 1, take away, and it's going to be 1 over x to the power of 1 times, that'll be x to the power of a half, so add the powers together, that'll be x to the 1.5 or x to the 3 over 2, and that's 1 minus, I've got 1 over, so that's a negative power, so minus 3 over 2, like so. That's that, and then I can differentiate that. F dash of x equals, the 1 will disappear, minus times a minus is a positive, so then 3 over 2 times 1 is that, and x, and then have to decrease that by 1, so it's from minus 1.5 to minus 2.5, or minus 5 over 2. Part C, going to have to work this bit out to start off with, so as always I've got root x over x squared, so that's root x over x squared minus 1 over x squared. Root x over x squared is the same as we did over here. It's x to the half divided by x squared, so that's x to the minus 3 over 2, and then minus x to the minus 2. I've got to square it, so I've got to times it by itself, so I'm going to write it down twice, it'll be easier this way. Minus x to minus 2, like so, multiply them out. So first bit, x times x to the power of this times x to the power of this, we're going to have to add the powers, so that'll be x to the power of minus 1.5 and none minus 1.5 and minus 3, and then it'll be minus this bit, so that'll be x to the power of, have to add the indices, so minus 1.5, that'll be minus 3.5 or minus 7 over 2, and then we got minus x to the power of, or 7 over 2, minus 7 over 2 again, and then finally minus times minus is positive, and that'll be x, have to add the powers to the minus 4, so that is x to the minus 3 minus 2 lots of x to the minus 7 over 2 plus x to the minus 4, and now I can differentiate that, so f of x, f dash of x equals minus 3 x to the minus 4 minus, oh no, it's minus times minus, so it's going to be plus 7 over 2 times by 7 is just 7 x, and I have to decrease it by 1, so from minus 3.5 to minus 4.5 or minus 9 over 2, and then finally minus x to the minus 5, and then finally part D, running out of a bit of space, so first bit is 1 and then minus 1 over that, so it's minus, and that is x times root x, that's going to be x to the 3 over 2, but it's going to be x to the minus 3 over 2, and it's squared, so I'm going to got the same thing written down twice, and that equals 1 times 1 is 1, 1, and then minus root x to the power minus 3 over 2, and then minus another one, so that's minus 2 x to the minus 3 over 2, and then minus times minus is a positive, and x, that'll be x, add the powers will be minus 1.5, another minus 1.5 will be minus 3. And now I can differentiate that to get f dash of x. The 1 will disappear. Minus times minus is a positive. 3 over 2 times 2 is 3x, and that'll be to the minus 5 over 2 now, and minus 3x to the minus 4. And that's done.